Hi, welcome to Tea Leaves Programming. Today we're gaming like it's 1979. If there's one weakness about this channel, it's that I'm not quite contemporaneous. A game will come out, and while everyone else is covering it, I wait, let's see, 30 or 40 years in order to actually talk about it. But this time, I want to talk about a game that, if you're watching when I release this video, is being released today. It was over 2 years ago that I interviewed the creators of the new version of Chipwits. This is Doug Sharp and Mark Roth, and you can watch the video by clicking the pop-up on your screen right now. We talked about a lot of things. I had played Chipwits, which was an amazing Macintosh game back when it came out in, I believe, 1986. And it blew me away. This Chipwits is a programming game that was written in the 4th programming language. So there's already like so much going on here. Black and white game for Macintosh, written in 4th. It's like they made a game exactly for me. Well, anyway, it's coming out. It's being released, and it's being released today. So I am not going to do a full Let's Play of Chipwits, but I did want to show it to you. So let's take a look. The demo for the new rebooted Chipwits has been out for a few months now. The full game is releasing on Steam in 2 hours as I record this video. By the time this video is published, it will certainly be available for you to purchase, but the demo should still be available, so go ahead and grab it. Mark and Doug graciously provided me with a review code, which I will be using. This does create a small problem for me because it's very important to me that I give my money to developers who are making cool things. So I'm going to have to buy a gift copy of this game for someone. The nostalgia is thick. I first encountered this game my freshman year of college. There was one kid who had his own Macintosh. And in 1986, at colleges in the US, this was incredible. Not a lot of my co-students had computers. You know, it was, I would say, maybe 1 out of every 30 kids had a computer. If you needed a computer, you went to the public computer labs, or clusters as we called them at Carnegie Mellon, and used them there. But this kid not only had a computer, he had a Macintosh, which was, those were expensive back in the day. And to see a game which was all about, more or less, computer programming. I've covered games like Robot War on this channel. Those existed, we knew about them, but they were unusual, right? Most games were kind of arcade games, you had your adventure games. Programming games were so specific. It really felt, as a nerd and someone who liked programming at the time, that, oh my God, someone is out there making games just for me. Well, it's 2025, and Mark Roth and Doug Sharp are still out there making games for me. Hopefully not just for me. Well, let's go ahead and see where we left off, where I left off when playing. I believe I got through the kind of first level of tutorial games or tutorial levels. All right, so let's jump in. We're going to help Professor Chip open a Chipwit factory. And you could see there are a number of harder missions here, the challenges, and there's also classic missions from the original game. But we're just going to continue the story mode here. All right, let's hop into chapter 2 here. I really like the way that the game has kept the sort of primitive art style while, spicing it up with a lot of color to make it more approachable for modern players. Eat all the cubes. Pick up exactly 3 prototype cubes. Now, a question I don't think I asked Mark and Doug was whether they had played, I shouldn't say played, or seen Richard Pattis's Carell the Robot, which I've also covered on this channel, and I will put a link up that you can click on to go to my discussion about that. So the cubes, or the widgets here, are equivalent to the beepers that we had in Carell the Robot. We're going to try to pick them up and put them down. And it's probably going to introduce sensors, which are going to be something that we can conditionalize on. To eat an item, use the pick up operator. Skate around that one loose tile right here. All right, so here is our workshop area. It's modeled, rather than being a bunch of lines of programming code as in Carell the Robot, it's modeled as this 2D grid, and in each location we can put a grid which is more or less equivalent to one computer instruction. We have some choices here. We have skate, which is to move. Junction allows us to connect up. It's basically a go-to. Loop is a loop, and pick up. I believe my memory from 1986 is that it takes a little bit of getting used to, but pick up actually picks up the thing one square in front of you. So let's do a test run here with just this one chip in our program. And sure enough, it does have to be in front of you. And now, when it reaches the end, when the flow of control reaches the end of the program, it implicitly loops. And you could see my robot, who I named Penelope Bootloader. Good robot names in this game. We can pause. There's also a way to single step. So if we single step, we can follow the flow of control here. You see the red highlight telling us what is operating. And let's get out of here. Can I turn off auto looping? I don't think you can. I think you always have a flow of control. Let's, just to be bloody minded, let's skate forward and try to use that pickup. And what I expect to happen is it will miss the cube. It'll try to pick up the thing here. And let's single step. Can I? Oh, it bumps into the cube. Fascinating. I did not remember that detail. And we're going to skate into the hole here and die. That's okay. If you die, you start over. I see, I have not clicked on this because I want to do this without hints, but I see a little light bulb above the professor here. So I believe that he would offer a hint if I clicked on him. And the 2 probably indicates that I've got 2 hints available. All right, so how should we do this? Well, let's have him pick it up first. The flow of control follows these little arrows here. We can change the arrows, and thus so we can lay this out however makes sense for us. Okay, so I'm going to pick it up and move forward. 2. We don't yet have a way to count for things like looping. Our choices here are loop or don't loop. But let's go ahead and we'll do this very manually for right now. I'm going to skate forward 2. In fact, I want to go down here. Just do a little organizational for myself. You know what? And let's use these junctions just to really be super explicit. I'm not trying to be efficient. That's always my philosophy is make it work first and then make it efficient. And so then we're going to, if we pick it up, we're going to skate forward 1, and then we're going to turn 45 degrees. And I believe that's just a turn. It's not a turn and move. And then we're going to go right 45 degrees, and then we should be able to do our final pickup, and that should be it. I'm just using the junctions here. You can see the flow of control automatically goes to the next. There's no reason to do it other than to show you the junction in operation. We could replace that auto loop with an explicit loop just to see how that works. Oh, That needed to be a 90-degree turn, so I screwed up. So to edit something or to change it, just go ahead and click on it. You could see that our skate command has essentially a parameter here. If we click on that parameter, we can change it. And hopefully now I've got it right. Once again, when we do the programming videos, I always try to emphasize that making mistakes is like, if you're not making mistakes, you're not a software developer. That's how I feel about it. The mistakes are how we learn and grow. So even in a game as simple as this, I am still making mistakes, and you will too. Let's go on to the next puzzle. Eat some more widgets. Cubes and cylinders. Pick up 2 cubes and 2 cylinders. Nice. So we can make this as fast or as slow as we want, up to, looks like 4x. We'll set it on 2. 1, 2, pick up. 1, 2, pick up, turn left. Trying to see if there's a pattern that will let me get exactly, see, I'm facing that way. So let's move forward. Let's just do this naively at first. Then we can turn that way and move forward. You know what? No, I think this one, rather than doing it ad hoc, let's try and do it as a loop with a minimum number of components. So forward, pick up, and then we want 2 more forwards. And then we want to turn right 90 degrees. And at that point, I think we're good. And let's put an explicit loop to show how confident we are. Let's also pause here and let's single step through this last iteration of the loop just to show how single stepping works. Forward, pick beeper, as I think of it. And we get our score here to show us how we did. Our score is actually pretty good. We made it, a lot of people, looks like, went for just the put down explicit commands for everything. A few people did the loop, so we got the close to the minimum number of chips. Someone did this in 3 chips. I do not know how that's possible. I'm not going to get sucked into optimizing on a video. That's for later. All right, so we have a branch here. That one's medium difficulty. You know what? Let's go forward because I suspect they're going to keep introducing elements here. So let's take a look at those being introduced. Pick up, oh, a strafe chip. Okay, so we got a new way of moving here. Ooh, speed upgrade. Okay, so I am over here. One problem I had in the original version is I keep looking at the professor and thinking that's my robot. No, my robot is this purple guy over here. All right, so we can do this. We can do this in one pass. So there's a thing in front of us. We're going to grab it. We're going to turn around 180 degrees. And grab the next thing. I hate having to do that. And then we're going to strafe. Oh, the problem here though is each time we turn, we're going to be facing a different direction. So we're going to need to reset after we strafe. So we will strafe right, and then we will turn around 180 degrees again. And then we'll loop. So there's probably a way to do this, which is if we spent more chips, and this is very common in programming games like this, there's a trade-off between basically memory space and speed. Oops. All right, let's go. Yeah, this is going to work fine. So how would one optimize this for even fewer cycles? I feel like that last turnaround is expensive. So if you really wanted to get fewer cycles, what you could do is spend more chips to either conditionally, once we have conditionals, or simply spend more chips to avoid that one unnecessary turnaround. So this is our score, chips, cycles. The world record is 45. Yeah, I think if we spent more chips, we could get down to 45. I'm not going to do it. I'm going to be strong. I'm going to keep going. We've got some plot here. The original Chipwits, my recollection, was very light on plot. And so we actually have a campaign here that I think helps introduce these concepts one at a time. And it's nice. Ooh, we're alluding to calculus. How nice. So I'm not sure what are we introducing here that's new? That's something that I always like to think about. I'm not sure. So let's grab that. Go forward. And at that point, we should be able to I only have, I see what we're doing here. Okay, great. So I'm like looking at this like, how is this any different from what I've done earlier? And the answer is there are limited resources. So let's get rid of all of these. Right. You see that one there means we have exactly one pickup command available to us. So we're going to have to figure out how do we loop this. So this level is basically forcing you to loop. That's good enough. So we're going to pick it up. We'll just move forward twice and turn left 90 degrees. And then we are basically reset for the next iteration. What happens? Can we use these as loops? And if we do use these as loops, do these count as chips for purposes of the score? Let's find out. We've got 1, 2, 3, 4, 5, 6 of these conduits, and we have 4 real chips. Let's turn the speed up all the way. Okay, our chips this run 10. So that implies that those are actually considered real chips. Let's replay it. I really want to answer this question of how many, like what do, if at any point I want to optimize the score. So will the auto loop count as a chip, and will an explicit loop count as a chip? I expect that the explicit loop will. This should be 5. No, 4. Okay, so our loop does not count, but junctions do. That's good to know. Okay, again, that looks like the goal. This is an optional harder level. I'm going to continue to plow towards the goal because I think that it will be more interesting to see them introducing the new mechanics. And I expect that the harder levels are simply applying the existing mechanics in different ways. Oh, so this time, rather than limiting the number of chips, although they may be doing that also, they're limiting the number of cycles. 50 cycles, we need 5 items in 50 cycles. Each pickup or loop. So skates are 3 cycles. It's like a 6502. Different assembly language opcodes use different numbers of cycles. Okay, great. Let's try it. So they said each skate operation consumes 3 cycles. That means turning is considered a skate operation. So turning to try to get these things will also use cycles. So it feels to me like our best bet is to try to go forward and minimize the number of turns. I'm going to try and do that kind of path with a loop. All right, so we skate forward. That's 3, 4. Skate forward again. That's 7, 8, and we're here. But then that leaves us kind of in the wrong position. You know what? I think if bumping into things is okay, this will actually minimize our number of cycles. And then let's turn right. And let's call that. I expect there to be some bumping, but I think this should get us to 5 within 50 cycles. Let's see if it works. No, I counted wrong. Actually, it should still work. Ooh, but now we're in a... How many have we got? Nope, that did not work. What did I do wrong? I think I was thinking that I'm picking up beepers when I'm on them, and I forgot that I'm picking them up when I'm in front of them. So... move, pick up. Move, move, pick up. Let's try that. Pick up. It's going to turn, bump, pick up. Move, move, pick up. It's going to turn. Okay, so we've got our bumps, but this gets us to 5 things picked up, which is great. In fact, we've got more than 5. Wonderful. We've got our widgets. So widgets are the currency. Widgets are the actual goal rather than these circles that we've seen. But we're probably going to get a new cutscene. Let's watch it together, shall we? Closed box. All right, so we're facing that way. I still don't have any sensors, so this ends up having to be very manual. Pick it up, turn around 180 degrees, and then we can strafe left. 1, 2, 3, 4, 5, 6 times. At some point, I'm going to get the ability to count. What happens when we reach the end? This is pointing down now. 4, 5, 6, and we can move it. We can point at a different square if we want. Or we could use junction boxes to move them and drop. If I've counted correctly, that should work. Let's move up the speed. Lovely. There's a group of people that I'm on a forum with, and I play a lot of these programming games with them. And whenever these games have leaderboards, I am always hit with the humiliation that they are always, at all times, getting better scores than me. So I'm personally very glad that the leaderboards here don't list names. Exactly 4 closed boxes. And one is already there. Okay. But how do we do this? I think we can do, if we write this loop correctly, we will take 1, 2, 3 of those boxes and put them here. 1, 2, 3. So let's, assuming we are standing right in front of the box, we're going to grab it. We're going to strafe right 3 times. 1, 2, 3. We're going to turn 90 degrees to the right and drop a box. And now we need to reset for the next position. We're going to strafe left once. No, you know what? We'll turn first. Turn 90 degrees left. Move forward 1 and strafe left 3 times. And at that point we should be reset right there. It should let us do the next one. Let's take a look. There we go. All right, we're getting there. So now we're introducing different types of items. So far, this has all been very, move beeper, pick beeper, put beeper. But at some point, we need conditionals because we're going to need to distinguish between what's a box and what's a pie. And we have now introduced the conditional command. Wonderful. The if feel operator. If you feel a pie directly in front of you, it will follow the T branch. Otherwise, it follows the F connector. All right, so this is where all this time you've probably been watching me placing these chips on this 2D board, and where do you put them? Does the structure actually matter? This is where that starts paying off. So we're standing in a certain direction. We don't need to move to finish this. We're going to drop our one if operator. And if there is pie in front of us, then we want to eat it. And if we eat it, I'm going to be clever. After we eat it, actually I have to be clever because they've only given me one skate operator. So let's see if you can figure out what we're going to do. Turn right, 45 degrees, and then loop back to the beginning. If the pie is not there, then we don't want to do anything at all. Right? Actually, that'll work fine. No, it won't work fine because we'd also like to loop. We'd also like to turn in that case. So we could use junctions to do this. I'm going to be very bloody-minded. I'll put that there. I want to minimize the surface area that I'm using here. And then this will need to be a junction to actually connect up to our loop. There we go. Nice. We've got sensors. Rocky's Boots reference! Tea Leaves has also done a video about Rocky's Boots, which, for my money, might be the greatest programming game ever made. It was created by Warren Robinette, who also created the Atari 2600 adventure game, and the slightly more well-regarded, although for my money not quite as good, game Robot Odyssey. So, I love you guys because you put Rocky's Boots in this game. Thank you. Once again, someone did this in 3 chips. How did they do that in 3 chips? I'd like to know. All right, I think we're going to finish chapter 3, and then I'm going to call it. I think I'm probably already showing too much of the game, but I'm having so much fun that I want to keep playing. So if this is meant to convince you to buy the game, I hope it's doing its job, because you should. Put the blue boxes in the blue area and the regular boxes in the yellow area. Okay, so there must be some way to sense what type of box is what. And there's a new argument that we use together with if feel. Okay, so we're starting out with it right in front of us. If I'm honest, I don't love the pointing finger as the glyph for if, but I don't know what you do, like a question mark? It's a tough question. All right, so it's going to be if blue. So blue is an attribute, so anything blue we would pick up. And it's annoying that, to me, that I can't do this. I was going to say it's annoying to me that I can't do this sensing to something that's already in my hand. It's only the thing in front of you. Nope, it looks like if feel is only the object on the floor in front of you. All right, I'm doing it again. I'm like worried about efficiency. Let's not do that. If I really wanted to, I could pick it up, put it on the blue space, and then special casing. You know what? Let's do that. I like that. I like coming up with unnecessarily complicated solutions. And in fact, they've given me 2 pick up and drop. So they're almost inviting me to do this. Okay, we're going to pick it up. We're going to turn 180 degrees. We're going to drop it so that we can feel it. Then we're going to ask ourselves if it's blue. If it's blue, we're done. Well, if it's blue, we're going to strafe. We're going to turn around and then strafe 1 to the right. And that puts us ready to start all over again. Why is that auto loop there? That's weird. Shouldn't be there. If it's false, if it's not blue, then we need to pick it up again, skate forward 1, drop it, and we're here at that point. And then we're going to skate backwards. And that should leave us, that should put us in the right place. Move these down here, and then I will use a junction here to bring us here. All right, I think that's right. I still don't understand why there's this auto loop floating in space here. Let's see if I counted right. Pick up, backdrop? Is it blue? It's not blue, so move it. So far, so good. We're going to test the other branch here. That looks like it works. We'll speed it up here. Oh, and looks like we did pretty well. Again, someone has figured out a way to get one chip better than I think you should. I really want to know what's the technique here. All right, I'm not even going to finish this because I feel like at this point I'm just doing the game for you, and that's really something that we should not be doing. So, Chipwits 2025. It is out. They've been working on this for well over 2 years. It is both a throwback to a bygone age, but also a very clever update to modern sensibilities. I have actually tried to play the original Chipwits recently. It's very difficult to even get running under emulation at all because of some details of early Mac hardware and how it was implemented. But at the time, its UI was innovative. It hasn't aged all that well. The updates they've made for this is right in the middle of what one expects a modern UI to look like. They really did a beautiful job of making this elegant and easy to use and understand so that you could focus on the fun of solving the puzzles rather than on being frustrated about the interface. It should be on Steam, as I said, in about an hour or so. I hope if you're watching this video, you will go download the demo, play it yourself. It plays on Mac or Windows. I have not tested it on the Steam Deck, but I just assume it's going to work on that too. So if you get it, if you try it, come back, tell us in the comments how you liked it. I'd like to thank Mark and Doug for including me, both in their interviews several years ago and allowing me to interview them, and for having me on their mailing list, watching them on this journey to releasing their dream game. It's always great to see an indie game developer make their dream come true. You've been watching Tea Leaves Programming. We are still gaming like it's 1979. Thanks for watching.